Hello friends, my name is Almas and today we are going to look at linear search in an array. Let's quickly look at the problem statement of our linear search is. Given an array of integers, return a position of a search element if it's present in an array, else return -1. So as can be seen, you are given a number array where the number array holds elements of type integer, and as can be seen it's 49, 23, 67, and at the end you have 12. Remember that the array index starts from 0, hence below at 0th location you have element 49, at 9th location you have element 12. Now let's look at how does this linear search works. So the elements to be searched is 49. So what linear search will do, it will start from an array index 0 and will check whether the number that I want is 49 or not, comparing the element at index 0. So does that matches? Yes, it matches. So hence it will return you an index 0. While if the number is not present as per the problem statement, it is going to return me -1. As can be seen, 90 is not present in an array. While if you look at 67, it will compare element 49, i.e. it will start with index 0 and will say, hey, I don't match. Then it will move to index 1 and will compare 23 versus 67, it doesn't match. Move the pointer to third index, i.e. index 2, third element, index 2, and compare 67 versus 67. It's a perfect match, and hence I'm going to return 2 there. Let's look at the edge cases or the questions that you might need to ask the interviewer. So first question is, what happens when an element is not in an array? What should be the outcome? Here we said it's going to be -1. Maybe interviewer is expecting you a max value or a min value, or maybe a 0. Who knows, right? So it's better to clarify it with the interviewer. Next question, what happens when an array is null or empty? So if the input is invalid or there are no elements in an array, what happens in that case? Should we return -1? Should we return max value, min value, and so on and so forth? Can I apply linear search on any input or just numbers? So let's consider the array of a person where you have a ID, name, and age. Can I apply a linear search on a person array where I can search by an ID? Yes, I can. Can I apply it on the person with a name? Yes, I can. So it's not just restricted to the numbers, it's just not restricted to an array. The other data type, like for example linked list, you can use the linear search on an array list as well, or a linked list as well. Handling duplicate elements. What if I have two numbers with the same value and I'm trying to search? Should I be returning the index of both, or should I be returning the index of just one? So this is based on the use case where interviewer is expecting you to return all the indices rather than just one or two. Hence, it's very important to get it clarified with the interviewer. Moving to the next slide where we will explain how exactly linear search work. So let's consider the same array that we saw in slide 1, and we are going to we are trying to search for an element 12. So here is the code that I have searched for, that I have written. The very first line in that is going to check for whether my element or array is null or not. It's an invalid input, hence I'm returning -1 there. But in our case, it's not empty. It's not null. Hence, I will move to the for loop where I will initialize for the first time index value as 0, and index is less than number array dot length, where number array dot length is 10. 0 is less than 10. Hence, I will go in the loop and I will check if the number at index 0 is equal to 12. It's not the case. As can be seen, as can be seen, highlighted number is 49. Hence, I will move back to the for loop and I will increment the index counter. So now my pointer is pointing to the first element. Let's check whether 12 is equal to 23. It's not. Again, I will move back to the for loop, increment the index. I will search it again. 12 versus 67. No, it doesn't match. Again, increment the index. So index is going to be 3. 3 is less than 10. Hence, I will enter the for loop again. I will check the if condition. 21 doesn't equal to 12, hence I will move again the index value. 4 is less than 10, yes. So I will go into the if condition and I will check whether my number at index 4 is equal to 12. That's not the case again, hence I will keep on incrementing and I'm going to do that routine unless and until I'm out of the elements to check, i.e. the last element has been passed. So at the present we are on the 8th index. Now we increment the index to 9 and we are going to check whether the number at 9th location is equal to 12. Yes, indeed it is. So what we are going to do is we are going to return that index. Now what happens if it was not present? If let's assume that we were searching for 13, 13 is not present, we are at the last index, so index will increment to 10 and 10 is not less than number array dot length, i.e. 10. 10 is not less than 10, hence we will come out of the for loop and we will return -1 in that case. So this is a simplistic version of a linear search. Let's look at the time complexity and the space complexity. Very important for the interview, and you should know what the space complexity and the time complexity is. So the best case is O of 1, wherein you are going to get the element at the very first location and you're done. Like 49 in our example. While for the average and the worst case, you might get it at the end, just like what we saw, or we might get it in the middle, which is an indication of O of n, where n is the number of elements in an array. Talking about the space complexity, what is the space, that extra space that we need in case of a linear search? It's O of 1. We haven't utilized any array, linked list, or any other data structure to store the temporary result. So hence we have its space complexity is O of 1. So application of linear search. As we have seen, the numbers were in a random order. It was not in an increasing order or a decreasing order. Hence, we used a linear search in that case. Also, there is a counterpart of a linear search, which is a binary search, which works very well on the ordered input sequence. Next, when the list size is small, we should be using linear search. How small? Maybe 100 elements. Because binary search is n log n, if we try to calculate the value of n log n for 100, for example, it's always going to be more than the complexity of linear search, i.e. O(n). Next, in case of linked list, I would use a linear search because binary search has a prerequisite that your input needs to be sorted. It's the bad idea to sort a linked list because you don't have a randomness, because you don't have a locality of reference. It's going to be difficult to sort and then search for within the linked list because of the nature of the linked list, where you're going to sequentially access each and every node of the linked list. Hence, it's bad idea to use binary search, while here is the best case for linear search, where you're going to sequentially search for every node and you're going to move to the next point, next node, and next node you're going to search for an element. Alright, so we are at the end. Let's recap what we learned in for linear search. So we talked about what linear search is. Linear means sequential, where you're going to search for each and every element in a sequential manner, as we saw, going from 0 to n minus 1 index in an array. Then we looked at what are the important use cases or the edge cases that we should be considering and asking our interviewer. Then we looked at time and the space complexity. And then finally we saw the use cases of a linear search when we should be using linear search. That's it. Hope you have enjoyed the video. Please like the video, comment the video, share on video, and thank you for watching.